Just a reminder for those of you in class, I apologize, I'm going to rewind here for the recording. Just a reminder, when there are tickets due, they're due before class. I'll give you an exception this time. But if you're not sure what to submit, go to tickets on the website and it'll tell you what I want, right, or what to do. And right here it says completion certificate, email it to me. So you can take a screenshot and email it to me. So if you're not sure, you know something's due, and you probably got an email from me this morning saying this week in programming logic, and it said don't forget your ticket. If you're not sure what I'm talking about for you, that gives you 6-8 hours to go figure it out real quick. If it's a ticket, you'll find it under tickets on my website. Everything should be on my website. Last Friday, you also got an email from Midstate that looks kind of like this. I'm going to the registering for free software link under handouts. I have updated all of these this weekend. So you should have received an email from Midstate Technical College DreamSpark asking you to register. You fill in your first name, your last name, your email address should already be there. You pick a password. This is your 5th password. This one I control. Again, I recommend you make them all the same, at least for a while. Then the instructions say go pick the software that you want. Here's the list of software that, here's 2. Those are the only 2 you need for this class. Everything else is bonus. Once you learn how to install one of these and download it, the rest are easy. You need Visio Pro 2013 with Service Pack 1. We'll see that here in just a second. You need Visual Studio 2013 Professional with Update 2 using the web installer. If you use DVD on this one because you plan on burning a DVD, I hope you got Blu-ray. I don't. Downloads at 5 gig and that doesn't fit on a regular DVD, so I'm still trying to figure that out. How am I going to I'm going to give you a DVD with this on it when it doesn't fit? Probably going to have to go back to an old edition. But anyways, these instructions that I'm looking at are in registering for free software. You can continue to follow those instructions and then you go to this site. And you can have 2 tabs open. I think I have 2 tabs, not anymore. I used to have 2 tabs open. So let me go back on this one to registering, and on this one, I'm going to programming logic, handouts, installing Visual Studio. The good news is Visual Studio is relatively easy to install. You turn this on, you turn that off because they're flipped when they start. You turn all of these off because we don't need any of them. And then go, and then sit back and watch it grind for a while, because it will. Registering for free software, you need the Professional with Update 2. So if you go to DreamSpark, and this one I'm going to go to the DreamSpark link. Go to DreamSpark, here's Visual Studio, but which one do you need? Visual Studio Pro, don't take a test, so watch for Pro here. Where did I put it? Visual Studio 13, Update 3. There's a 3rd update now. Okay. Let's test. Visual Studio Express, holy cow. Professional 13 with Update 3. All my pictures are Update 2. That 3rd one's got to be brand new because it wasn't there last time I looked. So I chose Visual Studio. Might have to dig around to find these. If you have a little trouble, let me know. But this one is a DreamSpark. This one's a web installer, so that one's probably the DVD. Here's the web installer. That's the one I recommend. What that does is it downloads it from the web. Now, if you've got a really bad web connection, that may not work for you. You'll have to wait for me to figure out the DVD option. Those of you using Macs, forget it. This is a Microsoft product, does not run on a Mac. Only way it runs on a Mac is if you're running virtual machine. And right now in the networking class you haven't talked about virtual machines yet, so until you do, those of you with Macs are either going to have to do your work here at school or borrow somebody's Windows machine or something. So that was in the recording. It was a little tricky. I clicked on Visual Studio. Look for Visual Studio 2013 Update 3. Then scroll down to the Pro version. Don't want the Express. We don't need the Premium. It's even bigger. Okay, so here's Pro, Update 3, preferably, there's the web installer. Add it to your cart. I might be able to do that, but you can't do it on a Mac because I won't be able to install it, so it won't let me do it. Should have done it in a virtual machine. So you click on that, add it to your cart, then you're ready to go. Back here for the instructions, add it to your cart, continue shopping or check out. I recommend one at a time. Don't continue shopping, because if you choose 5 or 6 things, then you're downloading all night long. Click yes, I'll agree to the license agreement, and proceed. The next page includes your product key. Let's see if I can do that. Probably not. Here's my Visual Studio Update 2. This is the next page after you say proceed with order. This is your product key if you ever need it. For Visual Studio, you shouldn't need it. They're all the same for everybody. It should be installed automatically. But for other software, if you're downloading Windows, you're going to get a key. If you're downloading Project, you're going to get a key. Visio, you're going to get a key. You want to hang on. You can always find this key like I just did. Sign in and go to your account, and it'll show you your keys. You can only order one of these software once. But once you order it, it sits in your account, and you can download it lots of times. I'm not going to take the time to download. My instructions tell you what to do. You start here. Going back to the instructions. Click the Start button, then you see this page. Once in your lifetime, you need to click on this. It will download the Secure Download Manager. Then you install it. Then you download the SDK, or SDX, which is the software that you requested. So it's a little complicated. But that's why I have these instructions, so that you can follow them. Then you click on those, and then you start doing the instructions. Then you follow, then you just do the install. So where am I? One more time, I'm on my website, under handouts, 1, 2, 3 pieces for installing Visual Studio. I would say you want that installed by the time you come back from Labor Day. Either today or Wednesday. We're going to jump into it here so you can kind of see what it looks like. What Visual Studio looks like when it's working, because it's already installed on your virtual machines here. But you should be getting it installed on your home machines pretty soon. Again, those of you who only have Macs at home right now, you're out of luck. You'll have to do your work here at school. The good news is that's possible. Because early on, the assignments are relatively short. Questions? Yes? Rachel, right?
Can we use the Mac Lab if you don't have a class in it?
Yes, if there's no class in here, you may use it. Occasionally, you can drop by. Josiah picked a bad time today because I was lecturing, but some days I'll be in lab, and if I'm not up here talking, you can probably come in and use a machine, but the risk is to somebody sit at your machine. If that happens and I'm here and somebody's sitting at your machine, let's hook you up on a different machine. We can do that. But then you have to copy that virtual machine again and get it installed, and it's kind of a pain. A lot of $300, $350 laptops on sale this week at Staples and Best Buy, and get extra $350 later on. You might make your life easier by buying a Windows laptop and not worrying so much about this lab. But the answer to your question is yes, but if the machine's available. Other questions? Okay. Then let's put this back where it was. That's not what I want. Let's take a look at what you might have learned while you were using LightBot. Or at least what I'm going to tell you you should recognize for the future. LightBot has given you a lot of examples of things that you're going to use when you write programs in the future. For me. Remember when we talked about programming concepts, there were three basic structures that you need to build computer programming logic: sequential processing, decision processing, repetition processing. Just those three. LightBot does a good job of sequential processing. Kind of gives you an idea of repetition processing. Do it again, do it again, do it again. Okay. But what it doesn't do very well is decision processing. So for next time, on Wednesday, what I want you to do is continue with the LightBot process. All right, now give me a second, I'm going to arrange my screen here. I'm only recording that red box that you see on the screen, because that's high definition. It looks great on your TV if you ever want to watch my lessons on TV. But I'm going to go back if I can. Nope, I'm going to have to go to the home page. Forgot how to get there. More challenges, can't do that. Come on. I'm stuck on LightBot. Arrow here, do I go? No.
What do you want to go to?
I want to get back to the main page.
Like code.org?
Yeah, I could type it in. That's my last. Yeah, this is a separate page. It's LightBot. Let's see if it's, that's not it. There we go. Next time, ticket. Somebody said this is easier. I agree. So this is a 1-point ticket. I will log it to run through the Angry Birds, and there's also zombies in there. Angry Birds and zombies. Run through that. It's another 20 little puzzles, but somebody said it was definitely easier. And I agree. What I like about this one is it does a much better job of representing decision processing and looping than LightBot did. LightBot's a nice warm-up. This is a great follow-up. And that'll be the last one you do on here. However, if you wish, you can sign into these pages, and there are all kinds of options to continue on. The next one after Angry Birds is a drawing program that includes lots of loops, but I hope you like geometry because there's angles and things like that in there. There's more after that. You can do these till you can't stand it anymore. The only one I'm requiring you to do is this Angry Bird zombie one. It's another 20 steps. When you get to the end, send me another screenshot, and I will give you your 1 point. Questions about the ticket? Okay. And I'm going back to LightBot because now I want to talk about what you could have learned here, what you might have learned when you're doing LightBot. In the basics, there wasn't too much, right? Like the first screen, what could you have learned here? Actually, that's not what I want to do. Let's try that again. What could you learn here? Well, you learn what the commands do. A couple of your classmates had a little trouble getting the tiles to light up, and that's maybe because they didn't follow the instructions very carefully. They said, yeah, I know how to do this. Click, 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 click. In programming, I'm not too worried about you doing that because most of these programming commands you don't know anything about. You just can't wait for me to tell you about more of them. Right, but so the point here is we need two things. First, we need a clear program goal. Over here, right? I need a clear program goal. Light up all the squares. That's pretty clear. And then I need to fully understand what each command does. So this is the walk command, it walks forward, okay. This is the light command, which tells me to light up the tile that I'm standing, okay, I got it. And program me, press the commands, click them in here. When you're done, hit the run button. Gotcha. If you need any help, question mark floating around somewhere. Good luck. So now I can experiment and run. Oh. Darn, retry, it didn't work. This isn't even mean, it doesn't yell at you or anything. Okay. Another thing to learn about programming is don't be afraid to do the wrong thing. Don't be afraid to try stuff. What happens if I do this? What happened here? Did my machine start smoking because I wrote bad code? Did my computer crash? No. The worst that happens when you write code that doesn't work is your program doesn't work, and maybe you get an error message from the operating system or from Visual Studio that you don't understand. That's not bad. You go, oh darn, it didn't work. You may use more colorful language if you wish, just not here in the lab, and you try to fix it. These, by the way, you can click to remove. and then try again. That's the beauty of computers. Remember, they're very patient. You can give it bad instructions, they'll do them. You can say, stupid computer, this is what I wanted you to do, and they'll do that. And you're done. So that's what you could have gained. That's what you did gain from step number 1. Step number 2. In this puzzle, got some turns, some new commands, but in this puzzle you need what I call situational awareness. Which direction is LightBot facing? Am I going left? Am I going right? And then once I go left or I go right, then when I get this corner, which will I be facing? I'll be facing that way, so I want to turn to the right. That situational awareness is also very important when you're programming. What is the status of my program right now? Where do I expect my program to be at this stage, and then what do I want to do after that? I'm not going to do all these puzzles over again. If you didn't find it, this is the speed it up button. Oh, darn, missed one. I can drag it in between. See the little green line? And there I go. Okay, number 3. Some of these commands, and this is my solution by the way, some of these commands have side effects, like the jump command. What happens when you jump?
It goes forward.
It also goes forward. Right? And maybe the first time you did that, you didn't expect that. And what happens if you put 1, 2 forwards here and then a jump? Nothing, he just runs up against the wall here. Excess commands. Sometimes excess commands can cause trouble in programs, other times they don't cause any problems, but you don't want to leave them in there. Remember, my goal in this class is for you to write maintainable programs. Programs that somebody else can look at and understand. If you have excess commands in there, they might look at that thing for 10 minutes trying to figure out why it's there. And test it, and because they're afraid to remove it because somebody has said, yes, this program works, but it's excess. And so if I find excess commands in your program, I'll ask you to remove them by taking points away and offering you updates for removing them. So excess commands aren't necessarily good. LightBot's pretty forgiving. Some commands do different things in different circumstances. The jump command jumps up, but if you're already up, it'll jump down if it's appropriate. That's also true in other programming languages. That some commands, certain circumstances, do different things. Programs can be tested in parts. Nobody says that you have to write the commands to get him here and then jump and then go there. And you can write this in pieces and test the pieces. And particularly as problems get more and more complex, it's more and more important. So I'm going to say walk and jump and turn right. Uh-oh. Situational awareness was a little off, but instead of a whole problem and try to figure out what was wrong, I've now got just a few steps and I can see what's wrong. So I can turn left and then take a step and turn left and jump. How am I doing now? Perfect. Add the step and the light. So you can build programs in pieces, a very important part. You can do this in Visual Studio, you can do this in JavaScript, you can do it in every language software developers you're going to learn. For networkers, you can do it when you're scripting. Write a script to do a few things and see if that works, if it works to that step, and then do it again and again and again. Add more and more and more stuff until the entire script works the way you want it to. You can test pieces. Generally, the programming will happen faster. I already talked about the unnecessary commands. What if I had left this as a turn left? Or I got to turn the wrong way, I want to turn right. So in here, jump and then turn right. What would happen? He'd be doing a bunch of jumping, and he never finished. So extra commands in LightBot's case don't crash your program. In the real world, extra commands can cause trouble. LightBot did not. When I told him to walk off the edge here, he didn't do it. stopped off automatically. Real programming languages will do exactly what you tell them to do. Tell them to walk off the edge, they will. Or at least give you some kind of warning that you probably shouldn't do that. Part 4. How many different ways can I solve this one? Well, my instinct is to go this way, jump over, and land on the square, right? But couldn't I turn left and jump, jump, turn right, walk, walk, and light the light? Is that less efficient or more efficient than my way? Worst piece, as far as I'm concerned. Could I take one step, turn left, jump, jump, turn right, walk, light it? Sure. Many cases, there's more than one way to skin the cat. Some are more efficient than others. Some are more, my term for it is elegant. My wife's a programmer. She doesn't like that term. She doesn't believe in elegant code, I guess. It's my term. Elegant code is what an experienced programmer would write. And what an experienced programmer would expect to see. And what a maintenance programmer is going to expect to see. So if you write code and I have a more elegant solution, in my mind, I will share it with you. If you disagree with me, then you know who wins. Me. Not necessarily. I'll try to explain it to you. But in this class, how do you find the most elegant solution? You don't. You find a solution that works. Your brain comes up with a solution. Oh, if I did this, my program will do exactly what I want it to do. If I know a better way, I will share it with you. In the real world, what do? Try 6 different things to see which one's most efficient? Not initially. What I do is my brain comes up with a solution, I code it. It works. Good. I have a deadline. I keep coding the next part of the problem. I don't go back and analyze this and see if there's 6 different ways I could do it and which one's better. I don't usually have that time. Now, if I finish my program and it seems a little slow, then I might start going back to pieces of code and analyzing them. I might read something online that says you can do this and go, oh, that would really make this a whole lot, and I'll go back and fix it. But real world, unless you've seen the problem before, which is pretty rare, real world, you find a solution, you code it, you test it. If it works, you move on. You don't look necessarily for a better one. You count on experience. You will, as you gain experience, often on the job, find code that somebody else has written. You'll go, well, that's a lame way of doing it. Here's one line that replaces 3. Why don't we just do that? Well, first of all, be careful. One line may not be more efficient than 3. It might seem like it, but it might not be. But generally, one line's probably more efficient. So the point here is in this class, particularly in this class, when you find a solution that works, go with it. I don't want you spending hours trying to find a more efficient solution. Remember how fast our computers are working? Billions of instructions per second. How many lines of code are you going to write? 300 maybe in a big program? 300 into 3 billion takes about a millionth of a second to run your program. Okay, maybe a little longer, but not much. How much more efficient are you going to make it? In this class, you're not. So don't worry about it. If I know the way an experienced programmer would expect to see it, I will share that with you. Questions? Step 5, not much to do there except break it into parts. Okay. In this case, I would break this into parts. I want to get down here, so I'm going to jump, turn on the light, and jump. That should get me down to here. Somewhere there's a reset button. There it is. So we're going to jump, turn on the light, and jump. And I expect that to get me down here. Nope, because I didn't put in jumps. I said one thing, coded another. That happens. Okay, that's cool. Now, once again, we've got multiple solutions, right? Do I go left, do I go right? Doesn't really matter. So I'll go left for no particular reason. Take a step, turn on the light. Now, here's something that's a little tricky. Where's this turnaround command? There's no one. Stupid robot. So how do you get them to turn around? Most of you must have figured it out because you got your certificate. You take 2 turns, 2 steps, last light. You turn around by taking 2 turns. But again, break the problem into pieces. Test the piece. Particularly as they get longer, it's much better to do it that way. Part 7. In part 7, you have 1, 2, 3, 4, 5, 6, 7, 8, 12 boxes. And they say you can't use anymore. In the real world, there's no border that says this is going to take you 3 lines of code. This is going to take you 10 lines of code. You write as much code as you need to solve the problem. And so you had a little bit of a clue here how many commands it should take to fix. Real world, you're not going to run into that. Oops. Always sneeze during recording. Can never figure it out. Okay, procedures, part 1. What's that? That's what I call positive reinforcement. I will try to do that. I'm not very good at it. And most of you ignore it when I put it on there. I'll say, hey, this is a good job. You're making progress. Keep at it. Don't give up. You can do it. And after a while, you just ignore that and cuss at the score and say, what did I do wrong? Or why is focus so anal? And those kinds of things. But I will try to give you some positive reinforcement. You should be giving yourself positive reinforcement. When you break a problem into pieces and you make the piece work, you should be going, cool, I got that first time. And then the next time, oh, darn, missed it. But I know how to fix it. Good for me. Yeah, I'm sure you're patting yourself on the back. But you're making progress. I want you all to remember what programming was like before you knew how programmers thought this week. And then we're going to revisit it. Hopefully as a group of 25 or 26 of you, we're going to revisit it the 1st of December and say, look where you are now. Remember LightBot and what a challenge that one puzzle was? Now look at you. And look at what you've written. You're coming a long way. You're going to come a long way. So the positive reinforcement helps. Reusable code is stored in, here they're called procedures, proc. Many languages today call them methods. A method is a small piece of probably reusable code that you can use over and over and over again, maybe in more than one program, but at least over and over and over again in the same program. So in this case, I can see a repeating pattern. If it's something that you find yourself writing the same piece of code for over and over and over again, I will show you how to write a procedure, how to write a method. One of my favorites is called title case. Take text that's been entered haphazardly and capitalize the first letter of every word. I do that over and over and over again. And very few languages come with a good version of title case. And so I wrote my own. My wife's last name is O'Keefe. She likes the K capitalized. There isn't a single programming language in the world right now that when you say title case this will capitalize the K. So I wrote my own, and I use it over and over and over again in all my programs. And I've used the logic behind it in different programming languages. The logic's the hard part. Okay. So here I see a pattern, 1, 2, 3, 4, 5 steps. So I can make that my procedure, and you can define it first. You don't have to write your code first. Now up here, the other thing to remember whenever you write these procedures is you have to call them, invoke them. In programming terms, it's called calling it. We call the procedure. When we get around to it, I will describe this as an expert. Okay. I know the Ryan, right? Okay. Ryan's my expert. I'm going to embarrass myself on the recording until I get all your names sorted out. Ryan's my expert. I have hired him to teach this robot how to push step 5 forward, take 5 steps forward. And whenever I want the robot to take 5 steps forward, I call Ryan. I said, Ryan, do your job. And he pushes the robot 5 steps forward. So I call him. In this case, his name is P1. In all programming languages, you can give that a much better name, like take 5 steps. Call it whatever you like. Then when Ryan's done, again, I need my situational awareness. Where's my robot? He's right here facing straight ahead. If I'm not sure about the situational awareness, run it. That's where he is. Couldn't Ryan also make him turn right? Well, the next time I run the 5-step pattern, I don't need him to turn right, so that shouldn't be part of the pattern. So after Ryan's done his job, then I need to turn right, take a couple steps, turn right, and then say, hey, Ryan, go get that robot, do it again. And then turn on the light. So these repeatable patterns, when you find a pattern in your code, instead of copying the same code over and over and over again, is extremely common practice to put it into a function, a method, a procedure. Those three names are synonymous. Depends on the programming language. My iOS programmers are learning a new language called Swift, and it uses func. Doesn't even bother with the shun, it's just func. Stupid language, saved 4 letters, big deal. It's still a function. In C#, they're methods. In JavaScript, I believe they're functions. Every language is a little bit different. But they're the same concept. It's reusable code, code that I write once. I test it thoroughly. I know it works. I'm going to share my title case code with you. I'm going to give it to you, and it's going to work. I'm positive, because I've been using it for 3-4 years. It should be working. Otherwise, somebody would have found the error by now. Very handy to be able to do that. In Visual Studio, many procedures, many functions like sorting and searching have been optimized to such an extent that they don't even give you a choice anymore on how to do it. They just plug it right into the language, and you say, sort this, and it sorts it. So a lot of these functions that I used to write back in the day when I was learning to program, the ones that I used to write, they're built into the language now. You guys are so lucky. I'm going to say that about 20 times. Told my iOS programmers that today, because this new language, Swift, is a whole lot better than the old language that we used to use. They're so lucky. Programming has matured, and that makes your life a little easier, but in a way, more complex. Okay, so what else here? We can test this procedure separately. I tested it. Did it take 5 steps? Yep. I did that. All right, part 2. What are we supposed to learn here? Again, recognize repeatable patterns. 2 steps. Left, 2 steps. Left, 2 steps right. Oh, so the left is not part of the repeatable pattern. The repeatable pattern is just 2 steps, because he turns in different directions after each one to make this S shape. And you'll learn what's repeatable and what part of it is not part of the repeating, what belongs as a procedure and what doesn't. It's a skill, takes practice. Part 3. This box has a limited number. Again, you're not going to get that. Again, I'm looking at the pattern. 1, 2, 3, and light them up each time, turn right. 1, 2, 3, turn left. Oh, okay. So 1, 2, 3, light them up. That's what's my procedure. And then I call it 1, 2, 3 times. Once for here, once for there, once for here. Questions? I'm kind of harping on this stuff because it's going to come back again. I'm probably going to make you go back to Robbie and say, go back to Robbie. And if you have saved your situation, logged in, you should be able to go back to Robbie and not have to start over. Because unfortunately, you can't jump ahead if you haven't saved your situation or your progress. But I'll have you go back to Robbie. I'll have you go back to Angry Birds and do step number 7 again, because that's what we're going to be learning now in this unit. I want to refresh that thought process in your mind. I think this is going to be even more valuable than I'd imagined. Part 4. What if I walk, oops, walk, light, right? Is my repeatable pattern. Okay. And then I want to jump and turn left and do it again. Whoops, I forgot the P1. What's that? The light goes down here. The P1 goes up there. And then I want to walk. So that's P1, go all the way down the line. and then I want to jump up and turn right and do a P1 again. Well, you can probably already guess that's not right. Oops, you got kind of stuck. That didn't work. But notice now, it didn't work. But how the heck did he get here? Where's my problem? Well, I could go through each one of these steps, but if I had built this in pieces, I would see right away, if I pull this out, I would see right away that something's wrong. This says walk and then jump and then turn left. And I could see after just 2 commands that something's wrong. I want him up there already. I expect him to be up there. Oh, wait, there's a turn. There's 2 turns. Oh. So this turn goes in here. Now I can test that piece again. There we go. Now I'm ready to go. And then I can test the next piece, a P1. That should be easy because Ryan knows how to get him to walk. He's the expert. Good. But now I need a turn and a jump. And then I can do a P1 again. Now I need another turn and then a P1. If you build these in pieces, when there are errors, they're easier to track down because they had to be in the last progress that I just made. That's the beauty of building programs in pieces. It is so easy to do. It is so much harder when you don't to try to figure out what's wrong. Sometimes there's trial and error. We've already seen what happens when you make mistakes. Nothing. The program just doesn't do what you want it to do. So many people in the past, and I hope you're not one of them, that are afraid to try something in their programming language because it might, what? Break Windows? If you can crash Windows with your program, you pass the class. Skip the rest of the programs. That's not a challenge. I don't want one of you trying to say, I'm going to write a program that crashes Windows. That way I don't have to write all this boring stuff he's making me write. Believe me, if you can crash Windows, my stuff's a whole lot easier. I don't think it's possible. Never happened to me. And by the way, if your program doesn't work, there is not a flaw in Visual Studio 2013. Guaranteed. Occasionally that happens, right? There's an error in my program. In the program that I'm using, there's an error in it, occasionally. But not yet, not in this class. I have yet to find anybody who writes a program whose program doesn't work, whose fault is Visual Studio. That's not the case. What else have I got here? So that was step what? That was step 4, 5. Ooh, lots of lessons to learn at 5. In step 5, in the real world, we got 1, 2 procedures here. In the real world, you can create as many of these as you want. In the real world, you'll have dozens, hundreds, thousands. Your first couple of programs will have 4 or 5 of these procedures, and here we just got 2. But it gives you the idea of breaking patterns into parts and recognizing the patterns and repeating them and using them over and over and over again. Many shops, that's what we call a place where you do programming. Many shops, a programming shop, has huge libraries of methods that somebody has already written and thoroughly tested and been blessed by somebody and say, you can use this, it works. Your job, like any other library, is to figure out what's in there, what isn't in there, how to use it so that it works the way you expect it to do. It's like, again, building Legos. What if I built a wall and my son built a wall and my daughter built a wall? Could we take those 4 walls and make a room out of them? Yeah. To take the pieces together and put them together. Methods can invoke other methods. So in this solution, I'm going to write procedure 2 that does this little bitty step here. Take 2 steps and turn on a light. But when you run this, what happens? Nothing. Because you have to call the procedure from someplace. So for right now, I'm going to call it from main. Go ahead and do P2. That's another rule that some people miss. There's no rule that says main has to call P1 and P1 has to call P2. You can call them any which way you want. So now I can test that, and sure enough, he moved ahead and lit the light. That's good. Now procedure 2 is going to do 2 of those. And now I can test that. Cool. And turn right, turn right. Ooh, cool. Notice that the 5 block pattern only happens 3 times. So at the end of this, I think I can even turn right. Looks good. Now what? I want to do another P1 up here. And another P1. And I expect him to be over here looking that way. Situational awareness. Cool. Now what do I do? Take 2 steps to turn on a light. Wait a minute. I've done that before. Could I just go step, step, light with a turn? Sure. But I've got step, step, light right down here. So at this point, I can do a P2, a turn right, a P2, and I should be done. P1s and P2s mixed together, calling functions, and you name it, any which order you want. I think the key part here, if you haven't figured it out, is build these programs in pieces. Write 4 or 5 lines of code. Test them. Do they do what you expect them to do? Write a couple more, maybe 3, maybe 4. I guarantee you nobody sits down, writes 50,000 lines of code and goes, go, and hopes, because it'll never work. And when it's broken, where did it break? Who knows at 50,000 lines of code. If I write 4 lines of code and it's broken, I can pretty much figure it out it's here. If I write 3 more, these 4 worked. I write 3 more. Problem's probably in these 3. Sometimes not, but most of the time it's in there. So if you build your programs in pieces, you'll save yourself a lot of headache. Methods can invoke other methods. We can test methods. We have to call them, though. Part 6, lots of solutions. So let's see. Oh, was that 5 or 6? That was probably 6. This one's probably the one that gave you fits, right? And there are numerous solutions. Mine is up there. My solution says climb to the top, turning on the lights, and turn right. Or climb to the top, turn on the lights, and turn left. So this is turn right, and this is turn left. And then what I said is turn right, turn right, turn right. Oh, so 1, 1, 1. Turn left, turn left, turn left, turn left. PP22. So that was my solution. But there are others that work. Yours worked. You got the certificate. It didn't say, hey, yours isn't as elegant as Volcker. Maybe yours is more elegant than mine. This is what I saw. This is the repeating patterns that I saw. I tried to use the up, 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 up without the turns, and I really couldn't, with the limits that I had, I couldn't turn on the lights the right way. To me, that makes even more sense. Just everything except the turns. That makes a procedure all itself. Could have done that, but then you only need 1. Jump, jump, jump with lights, and then turn left or right, because that's really what it does for all of these. Some of you turned on this one first and then all the way through. Well, this one is actually at the end of that path, and that's the path I saw, this way. When you run this, there's an extra command at the end, because I make him turn that light on. It's already on. Oh, let's go a little faster, shall we? And watch. He would have taken that last jump and turned that on. In the real world, is that what I'd want him to do? I don't know. It depends. And that's why I wanted to write a command that doesn't turn at the end. It's just, this is my procedure. Jump light, jump light, jump light. And then use that in different ways. But the left and right turns were causing me trouble. I didn't get this one just by looking at it in 3 seconds and saying that's the solution to writing it. I tried 3 or 4 different things before I come up with this one. And I've been programming, what did we figure out? 75. So that's almost 40 years. Surprised the heart's still going. 40 years of programming, and I didn't see it right away. And I'm still learning new languages every day. Paul's back there getting ready to join me, learn a new language. It's the same as all the other languages he learned, right? Oh, by no means. Swift, the newest, latest, greatest language out there, supposedly. I think we've been analyzing it in my iOS class, still has some glaring weaknesses that hopefully they'll fix. Right now it's in beta, it's not even official. But there's always new stuff to learn in this career field. All right, so 6 has numerous solutions, none of them easy. And then finally loops. This is where I think LightBot, fails. This is not how you write loops. Right? You write some code down here, which is step light, right? Yeah, give me lots of nice hints. Good. Step light, except that goes down here. And then from up there, just call it? Almost never. Because of the limits of LightBot, that's the way they have to do it here. LightBot doesn't have a do it again command, so instead we say do P1 again. But how long would this work? If this was 175 steps long, would it still work? Yeah. In the real world, it doesn't work that way. You have to tell it when to end. LightBot, when somehow he senses that all the lights are on, he quits. How do you do that? Magic. We didn't tell him how. Real world programming, when you write a loop, this is actually called recursion, procedure that calls itself. That's pretty advanced code. It's easy to see here, but what's missing is how do I get him to quit? How do I get him to know that, wait a minute, you're done when you get here? Because in the real world, you have to figure that out. So these loops, okay. Not real thrilled. Notice how many comments I have about them. Not much. And when we get to the last one, I would kind of like to have a step light and make that a procedure. But then what? Repeat it 5 times. There's no way to repeat something 5 times here. Here you repeat it endlessly or you don't. Not real world. So LightBot it's still a good puzzle, still gets your brain working, still talks about procedures, but procedures that call themselves like this, that says go back to the beginning, it's got to have an exit. In the real world, it's got to have an exit. So LightBot's misleading you a little bit, but it's still a brain test. Okay, so your assignment for tonight is to go back in here and do the Angry Birds one. And when you do the Angry Birds one, there's one of 20. I want you to do all 20. But first, you have to learn, right? And I've already learned these, so it's kind of remembered. Actually, not yet. Okay. Give me tips. And these are a little trickier, but there's move forward commands. What do you think that does? Situational awareness, the bird can be pointing in a certain direction. Absolutely. And if you turn the sound on, as soon as the bird steps on the pig, game's over. What I like about this one, though, you can get it all in the screen here in my red box, is you can actually show the code for this. So let's test that real quick. Run. Doink, doink. Yay. Not going to turn the sound on. But I can show the code. And notice this. Move forward, move forward. Cool. What does that mean? Is there a computer programming command called move forward? No. There's no such thing as move forward in any language. The programmers who wrote this page with Angry Birds and zombies have said, take the bird, make him bounce forward 1 square. They defined that. They figured out how to make the picture of the bird move forward 1 square. And if you turn him, how to rotate the picture of the bird. How do you rotate a picture? You go into your favorite drawing program and you hit the rotate button, right? Oh, that's lovely. But how would you manually do that so that you take this dot and put it over here, and this dot and put it over there, and this dot and put it over there? Oh my God. Good news is, programmers a long time ago figured it out, and they've shared it with us ever since. So these guys probably borrowed some code someplace. But when you see the show code and it says move forward, trust me, there's a whole lot more in there. Later on, the zombies are moving forward, and little radars coming out of their head. That's part of the move forward command. Those are functions that somebody has written to make this game easier to play. So you don't have to give it the command to move 1 pixel of the bird at a time to make him move. Wouldn't that be a pain? And no fun. So please do those. I think in the next class I'm going to tell them to do that afterwards, so that they're paying attention to all this good stuff. And yes, there's things to learn there. But what's really nice about these is as you move ahead a little bit, you start adding more. And these videos, I think, are really good. So if you're skipping them because you're just in a hurry to get the assignment done, you're missing out. Especially old Zuckerberg. He's really interesting. But now, look at this repeat. 5 times. Or if I want to, I can change it to 4 times. That's more real world. Do this a fixed number of times. How do we know how many times? 1, 2, situational awareness. 1, 2, 3, 4. Move forward. And turn left. And then do it again. What's missing in Angry Birds is functions. So LightBot teaches you about functions, but it doesn't have good loops. Angry Birds is great with loops and if statements, decisions, but it doesn't have functions because now what do I want to do? 1, 2, 3, 4. That's not even enough, is it? I got to do it 5 times. And I think there's a way to speed him up too someplace. Well, he's really going slow. There's got to be a speed up button somewhere. And once again, Bird's happy. Okay. But if we show the code, do yourself a favor every now and then, look at the code. I'm going to talk about this because this is important as well. What the heck is that? You'll see, Unit 6, sometime just before Thanksgiving, you'll get to that. But you've already used it. You've already seen it in action conceptually, which I think is going to be very, very valuable.